Hello kids, welcome to Expert Guidance. Your paper 1 chemistry is just around the corner and you're very anxious about the upcoming exam. Here we have made a complete revision summary for all the topics of your paper 1 chemistry. So to remind you, in paper 1 chemistry you need to go over atom, atomic structures and mixture, the periodic table, the structure and bonding, quantitative chemistry, chemical changes and energy changes. And this video is focused on the first topic, the atoms, elements and compounds and mixture. In this video, we'll be covering how you define the atoms, elements, mixtures and compounds, what is the difference between compounds and mixtures, and what are the various techniques to separate the mixtures. So in your syllabus, there are 5 techniques that you need to go over. That is the distillation, crystallization, fractional distillation, filtration, and chromatography. So let's begin. Now, the first thing that you should know is distinguish between atoms, elements, mixtures, and compounds. Now, let's start with atom. Atom is the smallest particle that makes every matter. So anything that has space and occupies volume is a matter, and that will be made up of atoms. An atom consists of subatomic particles, electrons, protons, and neutrons, and it is these atoms that combines to form elements, compounds, and mixtures. Now let's look over what are elements. Now elements are those substances which are made up of only one types of atom. Now there are more than 100 different elements and each have different properties. Like gold is shiny, whereas gold is solid, whereas carbon is an element which is a solid, but oxygen is a gas. So every element has different properties and they can be categorized as metal, non-metals, and semi-metals. And where do we find all the elements? We can look over all the elements in the periodic table, which represents all the known elements in the order of the increasing proton number. So we'll be looking next in the further videos what is a periodic table and what information it gives us. Next is mixture. Now mixture is something, if you just mix sand and water, you mix salt and water. So these are the 2 substances which can be 2 different elements or compounds which are just combined without any chemical reaction. So in mixture, all the components retain their properties and you can easily separate them by physical means like salt and water, sand and water, oil and water. On the other hand, when 2 elements or atoms, they combine together via chemical bond and each element do not retain its property, like methane is 1 carbon and 4 hydrogen atoms joined together, and the properties of methane is completely different from carbon and hydrogen. So this is what a compound is. So compound has a completely different properties than its constituent elements. Okay, so I hope now you are clear with the difference between atom, elements, mixtures, and compounds. Now, where do you find the periodic table? You find the periodic table, all the elements arranged in the order of the increasing proton number. So hydrogen has a proton number 1, is placed first, followed by helium, lithium, and beryllium. And you can see this periodic table in the forms of groups and periods. So these vertical columns are the groups and these horizontal rows are the periods. And if you look at this, we draw a zigzag line on this periodic table. All the elements to the left of the zigzag are all metals and all the elements to the right, which are colored yellow in this image, are all non-metals, and the ones which are there in the zigzag are the semi-metals. Semi-metals or the metalloids have the properties which are both metals and non-metals. Now, elements in the same group, like group 1 and group 2, all have similar chemical properties because they have same electrons in the outermost shell. So group 1 will have 1 electron in its outermost shell. Group 2 will have 2 electrons in its outermost shell. Okay, so just by looking at the periodic table, there are a lot of information you can get to know. Like lithium and sodium, they all belong to the same group. They have 1 electron in their outermost shell. Magnesium and calcium will have 2 electrons in the outermost shell. If anybody asks you, give an example of a metal, you can give any example from this group. If somebody asks you name a non-metal, you can give anything from this group. And the last is the group 8 that are noble gases. Noble gases means they do not react. And we look into the subsequent videos why they do not react. So this is just the basic of periodic table. Just by the glimpse of the periodic table, what information you can get. Next is you have seen a lot of chemical equations. So you can see in this chemical equation, there is carbon and there is oxygen. So 1 mole of carbon, what does the chemical equation tells you? The chemical equation tells you that there's a symbol, carbon, oxygen, carbon dioxide. 1 mole of carbon reacts with 1 mole of oxygen, forming 1 mole of carbon dioxide. Now, you can further refine this by putting the state symbol. State symbols tells us that at the room temperature, what is the physical state of these elements. So carbon exists as solid, oxygen exists as gas, carbon dioxide exists as gas, and if there's a symbol that has liquid in it, generally we use it for water. That means it's liquid. And if there's any element which is in solution, we use the state symbol aqueous. So in chemistry, you should always develop an habit of writing a balanced chemical equation with the state symbols. Okay, so as we'll do different equations, we'll try to use the state symbols in them. Okay, now balancing equation. Now balancing equation is based on the principle of law of conservation of mass. Now what is law of conservation of mass? That the mass can neither be created nor destroyed. So there are equal mass of reactants that are being reacted, and the mass of the products will be equal to the mass of the reactants. So now let's look at this question. Can you see there's carbon and oxygen and CO? How many atoms of carbon are there to the left side? There's 1. And to the right is also 1. But how many oxygens are there to the left? There are 2. And to the right, oxygen is just 1. So to balance it, always remember, you add the number in the front. So we'll put 2 in front of CO. So that makes the oxygen atoms to be 2. So now our oxygen is balanced, but now it has disturbed the carbon. Now carbon is 2 to the right and 1 to the left. So we'll write 2 in front of the carbon as well. And now this equation is actually according to the law of conservation of mass. There are 2 carbons and 2 oxygen to the left, so means it has the same mass, and 2 carbon and 2 oxygen to the right means it has an equal mass of products and reactants. Now always remember, this law of conservation of mass is only valid if the reaction is carried out in a closed system, because if anything escapes from the mixture or the reaction mixture, then the product mass will not be balanced with the reactive mass, and this law seems to get broken down. Okay, so you need to remember law of conservation mass is equal number of reactants and products, and you write the balanced chemical equation showing the equal number of reactants and products on both sides. Next is a very important question. What is a difference? What are the differences between compounds and mixtures? Now here I have tabulated the differences between compounds and mixtures along with the bases. So compounds have fixed composition. So if you talk about water, there'll always be 2 atoms of hydrogen and 1 atom of oxygen. In mixtures, you have variable composition. You can put any grams of sand mixed with any grams of any volume of water. Compounds cannot be separated by physical means, but mixture you can separate by physical means, like you can do evaporation, crystallization, filtration. In terms of properties, the compounds has different properties than its constituents. For example, if we talk about water, water has completely different properties from its constituents, hydrogen and oxygen. In mixtures, all the components retain their property. Next is the presence of chemical bond. In compounds, the components are chemically bonded, but they are not bounded in in a mixture. The chemical reaction takes place in the formation of compound, but no chemical reaction takes place in the formation of mixtures. In terms of melting and boiling points, the compounds have sharp and fixed meltings and boiling points, where mixture do not have fixed meltings and boiling point. Example of compounds is water. You can see it's 2 hydrogen, 1 oxygen, methane, 1 carbon and 4 hydrogen, hydrogen chloride, 1 hydrogen and 1 chlorine. Whereas mixture could be salt and water, sugar and water, oil and water solution. Now we know that the mixtures can be separated by physical means. Now let us look at what are the different ways we can separate the mixtures. Now there are 5 techniques you need to be aware of. First is filtration, which is used when you have a mixture of solid and liquid where solid is insoluble. So solid is insoluble in a liquid, so you can easily filter it off and solid can stick to the filter paper. Example, sand and water. In the crystallization, again, you can separate a solid and liquid, but in this case, the solid is completely soluble in the liquid. Okay, for example, salt and water solution, sugar and water solution. Next is distillation. Distillation can only be used when you have solid and liquid Where solid is soluble, you can also use crystallization, but in crystallization, the liquid is lost. It is evaporated. But in distillation, you can collect the liquid, or you can take two liquids which has different boiling points. Next, you have the fractional distillation. Fractional distillation is mixture of liquids where the boiling points are close together. Example, ethanol and water, or the mixture of crude oil. Or chromatography, where it's different components in a solution. For example, components in an ink. Now, these are the 5 techniques that we need to know for your paper 1 chemistry: the filtration, the crystallization, distillation, fractional distillation, and chromatography. Now, let us look at each one of them in detail. The first one is filtration. You must have seen this setup in your school laboratory where you have a conical flask which is placed on a glass tile, and then you have this filter funnel. This filter funnel looks like something like this with the tapering end, and inside it you place this paper, which is a filter paper. Now you pour your solution of a solid and a liquid through this filter paper. The solid component, which is insoluble in the solution, will stick to the filter paper, and the runoff will be the soluble solution, and which is known as the filtrate. So the solid component can be separated from a liquid using this technique. The solution runoff with soluble component and insoluble component like sand stick to the filter paper as a residue, and the runoff is the filtrate, which can be water or the solution with the dissolved components. And if it is just water, then you have your solution separated. If it is a water with any dissolved components, then you can do another technique to separate this mixture, which comes off as a filtrate or the runoff liquid. Now, the second technique which is used to separate the solid and the liquid with the solid completely soluble in the liquid is the crystallization or evaporation. So this is a setup that we use. We take a water bath and we heat the mixture in this water bath. And let's suppose it has a solution of salt and water. We will heat this mixture. All the water will get evaporated and the crystals of solid will start forming. So you have your solid components separated from the liquid. Next is the distillation technique. Now, in the previous technique, you can see that the water has been evaporated. But if we do any mechanism in which we collect this water vapors, condense it and collect it separately, then in this way, we can get both of these components. So the next technique is distillation. It can be used for a solid or a liquid, or it can be used for the mixtures of two liquids which have the different boiling point. You heat the mixture. One of the component which has the lowest boiling point will evaporate. Once it evaporates, it collects in the condenser cools it, and then you can have this component separated in a separate beaker or any flask. So distillation is used to separate solid and liquid, in which solid is completely soluble in the solvent. It can also be used to separate two liquids which are completely miscible in each other and have different boiling point. So in evaporation, the solvent is allowed to evaporate, leaving solid behind. But in distillation, solvent is evaporated and the vapors are passed onto the condenser, which cools the vapors and collects the solvent in a separate container. In case of separation of two liquids, the one with the lower boiling point will evaporate first and will be collected by the condenser. Okay, so now is a fractional distillation. Now, let's suppose you have the mixtures of more than two liquids, like of crude oil, or you have the mixture where the two boiling points are very close to each other. So in this, what we do is we take a fractionating column. So the vapors which pass to the condenser, they first pass this fractionating column which have glass bead in it. So the round bottom flask is fitted with a tall fractionating column with glass bead which is connected to a condenser. The vapors first evaporate into the fractionating column and hit the glass bead. The lower boiling point liquid will travel high up the column and reach the condenser and get separated in the separated flask. And the high boiling point liquids, they hit the glass beads at the bottom, get condensed, and it will come back to the flask. Okay, so I hope this technique is clear to you. You should know this setup. It's a fractionating column with glass bead. There's a round bottom flask. There's a Bunsen burner. There's a condenser which collects the lowest boiling point solution. Next is chromatography. Now, chromatography is a technique in which you separate the components in a mixture on the basis of their solubility. So I think you must have done this experiment in school. You take a chromatography paper. On this, you mark a line with the pencil and you dab the solution or a mixture that you need to separate. And then the solvent is allowed to run up. As the solvent passes the mixture, it will dissolve all the components inside it, and the components of the mixture which are more soluble will travel up, and the components of the mixture which are less soluble in the solvent will give a mark at the bottom. So in this figure, you can see that the yellow components are more soluble, so they traveled up, and then the red components are less soluble. Okay, so the components of the mixture which is more soluble will travel at a greater distance and will leave its mark near the top, and the component which is less soluble will have a mark near the bottom. Okay, so I hope all these 5 techniques are clear to you. You should be clear with where we use them and what is the process of doing this technique. Okay, so I hope this unit is well clear to you. Now let us look at what are the important key terms that we studied in this unit. We talked about atoms, elements, mixtures, compounds, periodic table, chemical equations, balanced equations, state symbol, filtration, crystallization, distillation, fractional distillation, and chromatography. What are atoms? Atoms are the smallest particle of the matter which contains electrons, protons, and neutrons. Elements are the substances made up of only one type of atom. Mixtures are the substances made up of 2 or more compounds which are not bonded chemically. Periodic table is a table that contains all the known elements in the order of the increasing proton number, arranged in groups in periods. Chemical equation shows a reactants and a product of a reaction. Balance equation shows equal mass of reactants and products in an equation. State symbol indicates the physical state of each element in its reaction, and thereof solid, liquids, aqueous, and gas. Filtration is used to separate an insoluble solid and a liquid using a filter funnel and a filter paper. Crystallization is a technique used to separate soluble solid from a liquid using evaporation. Distillation is the separation of components on the basis of boiling point. Fractional distillation is the separation of immiscible liquids with closer boiling points in a fractionating column on the basis of difference in boiling point. And chromatography is a technique used to separate the components of the mixture on the basis of their solubilities in a given solvent. So I hope these key terms are clear to you and you should remember them all. Now let's test yourself. You should name the technique used to separate the following: sand and water, salt and water, components of ink, mixtures of crude oil, and a copper sulfate solution. And then you have to label these ones as element, mixtures, and compounds: gold, water, carbon dioxide, sugar dissolvent water, and salt dissolvent water. And next is, how will you separate salt and sand? Okay, so you can pause the video, have a go at these answers. All right, so now let us look at the answers. So salt and water is separated by filtration, sand and water by filtration, salt and water by distillation, components of ink by chromatography, mixtures of crude oil by fractional distillation, and copper sulfate solution for crystallization. For salt and water, you can also use crystallization. Now, next is label as element, mixtures, and compounds. So gold is an element made up of only one type of atom. Water is a compound because it is 2 hydrogen and oxygen combined in fixed proportion. Carbon dioxide is also a compound which has 1 carbon and 2 oxygen. Sugar dissolvent water and salt dissolvent water is a mixture because these 2 components can be separated by the physical means and all the components retain their properties. Now, to separate salt and sand, what we can do, we can dissolve in water. The salt will completely dissolve in water, forming a solution, and sand will be solid. That will be there. We can pass this mixture to a filter paper. The sand will stick to it. We can take out the sand out of the filter paper, dry it. Now we are left with the solution of just salt and water. And for salt and water, we can use crystallization. The water will be evaporated, leaving salt crystal behind. Okay, so I hope this topic along with these questions are clear to you. Now, what's the next step? The next step is you check the specification, make sure the specification on this chapter should be crystal clear to you, and do exam questions on this topic on atomic structures. The exam questions can be found on my website. The link is shared with you in the description box below. If you like this video, then please do like, comment, and share this video. And also let me know in the comment section that what is the topic that you found most complicated in this, and I'll try to make it easier for you. Also, let me know if there's any specific video you want me to make, I'll do it for you. Till then, happy revising.